Hello students, I hope all of you will be fine. So today we are going to discuss some more plotting options which are built in and already available in the MATLAB package. So let us first go into the script file here and let me write here CLC first, which is a very good practice to include all these two options or commands here. So here first of all let me write here t equal to from 0 and having a distance between each point at 0.001 and here 1. Okay, so how many points will I have here? So actually if you want to calculate the number of points here, so first of all you have to write here, let me go to this, the initial point here is the 0, the last one is the 1 and the distance between each point here is 0.001. okay, so in order to find the number of points here, so what we have to do, first of all we have to write the last number and from it I have to subtract the initial number and writing the brackets here and overall divided over the distance between each of the point which I have taken here. And here as you can see that in the M file, this is the first point and this is the last point. So 1 minus 0 divided by 0.001. So from it I will get the total number of points which I have, and I have here 1000 points. Okay, similarly instead of this I can also use another command which is built into the MATLAB, and that is linspace. Okay, so in linspace what I can write here, I can write here the initial number, the last number, and instead of writing the distance between each of the point here I can write here the total number of points. So writing 1000 here will also serve the purpose which have been done by the command which I have used here with the colon here. Okay, so these are basically the two commands. Linspace is also one of the command and I can also use here instead of this one. Okay, so now I am using this one. After it what I have to do, let me write here again the sine wave. Okay, and the frequency of this sine wave is, let me have it 1 hertz and 2 into pi into f into t. Okay, so this is the sine wave, and in order to plot it what I can do here, I can write t and I can write y here, and then I have to save it, and PLTTING, let me call it plotting and save it. And now you can see that this is the plot which I have to see. Okay, I haven't added any title here, I haven't added the grids here, xlabel and ylabel as well. Okay, so this is the plot here. In order to see the separate points here, as we can see here that in order to, when I will reduce the points here, what will happen, the plot will not be clear here. Okay, just writing it here, I'll see that the plot is not very clear here because now it has taken a very less number of points, because now the number of points here are 10. Okay, why 10? Because 1 minus 0 divided by 0.1 is 10. So the first point will be here, second here, third, fourth, fifth, 6, 7, 8, 9th and 10. Okay, so the resolution is not quite higher. Why the resolution is not quite higher? Because the MATLAB package and all the available packages and softwares in the computer, we have all the digital packages. All the things they do is basically based on the digits, and after it what you have to do, they basically connect points which are available here. Okay, so in order to check the points here, what I can do here, I can also write here this, and let me write O here as well. Okay, so now let me, okay, now you can very clearly see that these are the points. This is first, second, these are basically 10 points which are connected by this line. Okay, so if the number of points are here less, so the resolution is less, and we have very small resolution and the curve here is not so crispy. So in order to increase it, increase the number of points here, what I can do here, I can increase the number of zeros here, and you will see that the points are now increased and the plot here is now crispier. Okay, this is one of the method, and Similarly, removing it from here, we can also see all the points here and also this one as it is. Okay, so these are all the points which we can see here as well. So this is basically not a very good way of looking at the digital signal. So in order to reduce it, what MATLAB offers us, there is another command here, and that is called the stem command. What does a stem command do? Let us now run it, and I will see that now this is a digital signal or discretized signal. Okay, we cannot call it the digital signal, but it is the discrete version of the sinusoidal wave, in which each sample has been separated from each other with the time of 0.1 instance. Okay, so this is, you can also call it the discretized sample. So in order to increase the discrete samples here, what I can do, I can decrease the distance between 2 points, and writing it here as well, you can see here that it has now decreased it. Similarly, if you want to decrease it some more, let me increase the distance here. So this is 0.9, and you will see that one point is here, the other one is here, and the resolution is not that much clear. Similarly, writing it 0.1, okay, it will be like this one. And also, if you want to use the same things which I have previously used, so writing K here for the black, and also the line width 4. Okay, so now running it, and I will see that it has been increased. Okay, and now this is the discretized signal. Now in order to use other options here as well, so writing grid here, and also the title, and the title is, let's say, signal sampling. Okay, so this is our signal. Okay, similarly, if you want to increase the frequency here, what will happen? Okay, so now with the increase of frequency, the number of points we have are lesser. So let me increase the distance between each point here, and I will see that now it is making some sense, because now the samples have been increasing, and this is all about the stem command here and the digital sampling, which is usually used in the signal processing. So thank you so much, and I will see you some more videos related to the MATLAB in our upcoming lecture.